Hi guys, in this video we are going to look at vector operations. Now this is not using components but geometrically, how we find the sum or difference or a scalar multiple of a vector. So first let's talk about the sum. Now for the sum we got two laws. One is called triangular law. For triangular law what you need to do is position your second vector where the terminal point of the first vector is. So you would have to draw vector W at the end of vector V. And W goes 2 to the left, 3 up. So it would be like 2 to the left, 3 up. So you would draw it like this. And then the sum would start at the initial point of the first vector and end at the terminal point of the second. So that's the sum, okay? Now, let me get rid of these things. So if I want to get rid of them, I just have to position the mouse at the starting point and then just drag the vector off the grid. So let me just go ahead and do that. I'm going to drag it and clear it. Okay. Now, what about the parallelogram law? For the parallelogram law, what you need to do is first you need to draw a line or line segment parallel to V. So V goes 4 to the right, 2 up. Okay, so 4 to the right, 2 up. So that would be like that. And then you would also draw another vector. So I can't start drawing over here because see, like it wants me to move the vector instead, but I can just draw anywhere and then later I just adjust the point. So that would be, if you made that parallelogram, then the diagonal of the parallelogram would be the sum. So it'll start where both V and W start and end at that fourth vertex. Okay, so here though, for this question, they do not want you to show work. They just want you to draw the resulting vectors. So I'm gonna get rid of the, let me just get rid of this guy. And then let me also get rid of this guy. And then I position the other one correctly so that it's like a parallelogram, right? So it should go 4 to the right, 2 up, 4 to the right, 2 up. I think that's right. Okay. And then as far as the difference goes, here we only really have just one law. And the law says that the difference of these two vectors is going to be the third side of the triangle. But what you need to understand is where this thing is going to start and where it's going to end, because that's going to matter, because W minus V and V minus W are not the same. What you need to remember is that you're going to start where the second vector ends, at the terminal point of the second vector. So you're going to start at the terminal point of V, and you're going to draw a vector towards the terminal point of W, and that's going to be the difference. So why is that the difference really? So if you think about vector W, if you add it to negative V, what would happen? Well, what is negative V? Negative V would be a vector that would be like the opposite direction of V, right? The same length, but opposite direction. So it would be something like this. So if you were to add these two vectors, right? So the vector W and vector V or negative V, well, in order to add it again, you have to use the parallelogram law, but you're gonna get this vector as the diagonal of the parallelogram. So I'm not gonna show that. Let me just get rid of this guy. But this is what you should do. Just draw a third side, but start at the second vector and at the first vector. Okay, now as far as the scalar multiple, here we've got either a vector is just going to be the same directional as the original one, and the length is going to double, triple, or whatever is the number, or opposite direction if it's a negative scalar. So because it says negative 2W, we need to draw a vector that has the size of twice W but opposite direction. So twice W would mean, so it has to lie on the same line, right? So it has to be like this basically should be on the same line, but it should be twice as long. So let's see. I don't think this is right. So this goes 2 to the left, 3 up. So this should go 4 to the right and 6 down. There you go. So it has to lie on the same line, and the length of which should be twice as long as W.